Hello, my dear students. I am Mukesh Tilwani, Assistant Professor in MLB Textile and Engineering College, Bhilwara. The subject is manufacturing processes and topic is forming process. This is the second part of extrusion process. In first part of extrusion process, I had discussed about the extrusion ratio, advantages of extrusion, limitation of extrusion, applications. This is a classification I had discussed in earlier lecture, and hot extrusion process. What is hot extrusion process? I had discussed, and I also discussed the one part of the hot extrusion process, which is direct extrusion. From today, in this lecture, I am going to discuss the indirect extrusion and what is the cold extrusion and the types of cold extrusions. What is indirect extrusion? In direct extrusion, we had seen that in direct extrusion, the direction of the force, ram force, and direction of the extrusion part was same. But in indirect extrusion, the direction of the ram force, that means the line of force, line of action of the force, and direction of the extrusion part is different. And also in indirect extrusion, one of the problem in direct extrusion was there is a direct contact between blade, which is hot, and confining chamber. Due to this, the friction was occurring in direct extrusion, but this problem is not in the indirect extrusion, as we can see in from this diagram that there is no direct contact. There is no direct contact of the extrusion part with the containing chamber, so that the friction problem in indirect extrusion is reduced. So the required force is lower. As compared to the direct extrusion, it is 25% to the 30% less. In this process, the low process waste we found. Now the cold extrusion. As we have seen in the hot extrusion, mainly for doing the extrusion process, we prefer the hot extrusion, but for if the material already have the ductile property, then we can use the cold extrusion as well. In cold extrusion, we don't have any problem of design of die, because in cold extrusion the temperature of the raw material is less as compared to the hot extrusion, so that the corrosion problem in the die is reduced. Therefore, the design of die is not a problem in cold extrusion. Used with low strength metals. Low strength means ductile material, that is lead, tin, zinc, aluminium. These are all the ductile material to produce the collapsible tooth for toothpaste, medication, and other creams. We can cans for the for example, can for cold drinks. Nowadays, also being used for forming the mild steel parts. We can nowadays the mild steel part also can be cold extruded. We know the mild steel also have some ductile properties, so we can use cold extrusion for mild steel also. This is a type of cold extrusion process, in which this is a forward extrusion process, which is hydrostatic extrusion. Hydrostatic extrusion is very important process for extrusion. What is this? Hydrostatic extrusion is a process in which the blade is completely circumscribed by the pressurized liquid in all the cases, with the exceptional being the case where the blade is in the contact with the die. Here the blade is this is a blade. This is a blade part. This is a fluid circumscribed by the blade, but the one part of the blade is direct contact with the die. High pressure fluid applies the force to the workpiece through the die. How this process can occur? If we force from the ram, this ram force to the fluid, then fluid particles go away from the ram. So and give the pressure to the give pressure to the billet, which is a raw material. This pressure generate in all direction of the billet. Then this pressure will flow the raw material, that is billet, and the billet will contact with the die. Then after contact we get the extruded part. In this there is a one advantage in this process is that we have a fluid in this process, so we don't need any lubrication for this process. We can produce the brittle material in this process. It is a forward extrusion, as I have said, but the fluid pressure surrounding the blade prevents the upsetting. Billet chamber friction is eliminated because there is a fluid. There is not a direct contact of the billet with the container. Therefore, here the friction is 0, and the pressurized fluid acts as a lubricant between the billet and the die. Continue. Temperature is limited since the fluid acts as a heat sink, and the common fluids burn or decompose at the moderately low temperature. In this case, in this process, we have to use the cold extrusion process. Cold extrusion, why? Because if the temperature of the raw material is high, then the fluid will burn or decompose at the temperature. The metal deformation is performed in a high compression environment. Crack deformation is suppressed, leading to phenomena known as pressure-induced ductility. In this process, we get the high deformable part. So this process is used for when we need the high compression environment and we need the high deformation. Then this process will use. Relatively brittle material like cast iron, stainless steel, molybdenum, tungsten, various intermetallic compound can be plastically deformed without fracture, and material with limited ductility becomes highly plastic. As I said that in this process we can part the brittle materials also, like cast iron, stainless steel, molybdenum, tungsten. These parts can also be extruded without use any type of lubricants, because we have a fluid in this process. Without fracture, we can part these type of material from the extrusion process. Application of hydrostatic extrusion. Hydrostatic extrusion, with the help of this process, we produce the nuclear reactor fluid rod, cladding of the metals, and making wires for less ductile material. If we have the less ductile material, that is the brittle material, we can make the wire by use of hydrostatic extrusion. Lubrication used in the extrusion process. For hot extrusion, glass is an excellent lubricant with the steel, stainless steel, and high temperature metal alloys. why we use the hot estrogen. Hot estrogen generally used when we have the raw material of brittle in nature. When therefore in hot estrogen we have to use the lubricant which is a glass. And for cold estrogen, lubrication is critical, especially with steel, because of the possibility of the sticking between the workpiece and the tooling if lubrication breakdown. Most effective lubrication is phosphate conversion coating on the workpiece. In cold estrogen, lubrication is crucial, and it is very critical, because if we use the cold estrogen process in brittle material, then it is a possibility of the crack in this case. Therefore the lubrication is critical in cold estrogen. Therefore in cold estrogen we use the lubrication as phosphate estrogen. Thank you so much, students. This was the second part of the estrogen process. I have complete the estrogen process. Thank you so much. If you have any doubt or query, you can comment on. I will reply for that. Thank you so much.